Hello everyone, welcome to this video lesson. In this video lesson, we are going to solve a problem basing on one-dimensional motion. Let us first identify what is given in a problem. It is given that there is a car. It is starting from the state of rest. Its initial velocity is equal to 0. Its initial velocity equal to 0. It covers a distance s and continues with an acceleration. First of all, it has covered a distance s. So let us assume the body has started from a point A, it has reached a point B, it has covered a distance s, its initial velocity is 0, it has an acceleration a. So I can write a formula. In this case, v square minus u square is nothing but equal to 2as. Okay, I prefer writing because time, I want to write the problem in terms of the time. I prefer writing in terms of the time. I will use the formula s equal to ut plus half at square. S is given as S itself in the problem. U is 0. T we don't know. I shall not use T because in the another part of the problem that T is used. Therefore, I will call it like T1. Half acceleration is A and a T1 square. So I got a relation. S as half A T1 square. This is that I use as equation number 1. By this time it has reached the point B, that the body has acquired a velocity v, then we can calculate velocity after that specified time, after t1 seconds. I'll use the formula v equal to u plus at. U is 0, t is t1, so velocity is nothing but equal to at1. Then he said it is moving further, not with an acceleration but the same constant velocity. Therefore it's going to continue moving with the same velocity v for some time. The time is given like t. It has covered a distance something like bc. Then I can write, because it's covering a constant velocity without acceleration, the value of that bc I can write now as bc is equal to constant velocity that it has acquired. It has taken a time t. That's nothing but equal to vt. But v we have already calculated from the previous equation as at1. So I will write this as at1 and t. So the value of that bc, the distance covered, is nothing but equal to at1 into t. That's the bc. Let me use this equation as equation number 2. I'm going to use this further later stage. Now it has started further, it's moving further. It is deaccelerating, it's not acceleration, rather it is a retardation, minus a by 2, and finally came to the state of rest. I don't know by how much distance it has covered. Let me call the distance as CD. I will again use the same relation that we are using. I will use a formula, something like v square minus c square equal to 2as, because I know v and u. So between c and d, if I use a formula, v square minus u square equal to 2as. Final velocity is 0. Velocity at the point c is nothing but v square. A is nothing but equal to minus a by 2. S is nothing but equal to CD. So minus minus will cancel. V square is nothing but equal to 2a by 2. That 2 and 2 also will cancel. That implies CD is nothing but equal to V square. CD is nothing but equal to V square by A. Of course, there's an acceleration is there here. This acceleration is nothing but equal to V square by A. Let me call this equation as something like I want to compare this equation as CD is V square by 2A, but I know the value of that V already something like AT1. So what happens if I have substituted this AT1 in this equation? V square is AT1 as we have derived earlier. So AT1 whole square by A, that's nothing but equal to AT1 square. If you look at equation number 1, half AT1 square is S. Therefore, AT1 square will become automatically 2S. So this is 2S. I want to say this from equation number 1. From here, half AT1 square is S. Therefore, AT1 square taking the two other side, it becomes 2S. Now he has given the total distance covered in the journey. It is given that this total distance is given for you in this problem. If this total distance is given to you in the problem as 15 years, what is the total distance actually? AB plus BC plus CD is given in the problem as 15 years. We already know AB is yes. We have calculated the value of the BC as A, T1 and T. CD we have just now proved it as 2s equal to 15 years. So I can say A, T1 and T is 15s minus 3s is nothing but equal to 12s. So I got a value A, T1 and T is nothing but equal to 12s. Let me call it something like equation number 3. I want to divide this equation with the first equation because that is also in terms of A's and T1s. So I will do something like 3 by 1. This is 3. This is 1. Let us see what is this 3 by 1 gives. A T1T here is half A T1 square. Here is 12s and here is S. So S and S will cancel. A and A will cancel. 1 T1 also will cancel. So 2T by T1 is 12. Or T by T1 is 6. Or T1 is T by 6. Putting this T1 is T by 6 in this equation number 1. From 1 we can write S equal to half A. T1 square is nothing but equal to T square by 36. So what's our answer is going to be finally is we got a final answer is nothing but equal to A T square by 36 and 2 72. This is what our answer S is equal to. Thank you for watching. Keep coming for more and more video lessons.